Yeah, or recording and transcript start.
All right. Just give me 1 minute. I'm pulling up the slides. Yes, so I'll start sharing my screen. Is my screen visible?
Yep.
Yep.
Yeah.
All right, cool. So we'll start with the agenda of this second community call. We had our first community call exactly 1 month before, which was like on the 11th of February. So this is our second community call, and today we'll be sharing a few updates on the Enscribe channel, as well as we have guests with us from the Lighthouse team, and so we'll be discussing contract metadata with them, and then we'll also take few questions and answers in the end. So recently we've shipped the Ask AI feature, which is an AI agent into Enscribe that allows you to do contract naming, and you can ask generic ENS related questions. This was already demoed in the last ecosystem call, but we'll take a look at how it works and the design behind its implementation. We'll also be showing new API docs that we have added to our documentation. Enscribe does expose a couple of API endpoints for public consumption, and so we'll see how those documents, the API documentation looks like. We'll be then discussing how you can see contract metadata in the Enscribe UI application, how data is presented in an hierarchical fashion, and how you can navigate the different hierarchies. And then we'll have conversation with our guest from Lighthouse. So let's get started. So what Enscribe at its core allows users to do is basically name their contracts, right? That's been our mission. And Enscribe has additional features that allows you to also see details about contract. It allows you to see the metadata as well. But what we want to do is we want to make naming contract very simple. So it should be as simple as expressing your intent, which is to name contract, in a language that is spoken by humans. And so this was the primary motivation in simplifying naming your contracts, as well as additional operations that you can perform. So this is still in an experimental phase. So we are still trying to make it robust, foolproof, secure, but you can already give it a spin. So we'll see how that looks like. And what we've also done is the namespace team have developed an ENS MCP server that allows you to query a few things. For example, there's an ENS name called vitalik.eth. You can ask questions like who owns vitalik.eth or who owns abi.eth. And so we have extended our own MCP server, which is the backend behind this whole AI agent. So we've extended our own MCP server with their implementation, and so these queries are simply forwarded to them, and we kind of simply forward the responses back to the user. It's a neat way to build a federated sort of system with of MCP servers with this approach. So we'll see how that looks like. We'll go to the Enscribe app. Let me just refresh the screen. And so here we see, Ask AI option as the very first menu item. And then we also have the sort of legacy name contract UI, right? Which is also, pretty simple and straightforward. But what you have to do is enter data in these fields and, make sense of what to do where, and then click a button. So instead of this, what you can do is you can simply go to the Ask AI page and simply give it a prompt, something like this. So you can tell, hey, I want to, set a name to my contract, which is deployed on, this chain ID, which is Sepolia in this case. And you simply click on send. And yeah, it then builds, a transaction plan. So creating subname, setting forward resolution, reverse resolution. And you can do this by, clicking this yes, sign transactions button, which will then show you a pop-up of the connected wallet. As well as, we have this example prompts that you can ask the AI. So for example, let's say, what are the subnames under Vitalik.eth? And this is, using the ENS MCP server behind the scenes. So it tells us that there's one subname which is expiring in 30 days. And the other functionality that we have baked into the agent is to do bulk naming or batch naming, which is, again, we have sort of a UI page for it, where you can, upload your CSV file, and then, you can make corrections, etc. You can select your domain. But an easy way would be to simply ask the AI to do that. So, you can simply drag and drop a CSV file. This, it will automatically detect, there are valid rows. So this is nothing but a comma separated contract and names values in there, which looks like this. So, it's just the contract address and the name that I want to set. And we can simply say, name all the contracts in the CSV file. And so what it will do is, it will create these bunch of transactions for which, we obviously need approvals. And once we sign them, the bulk naming will be complete. So, it's as simple as just chatting away instead of, fiddling with the UI controls. So let's quickly take a look at how this is implemented. So the front end, which is this chat page, is where users enter their prompts, which are then, sent to our Enscribe API server, which we also call as intent server. And then from here, they go to the ChatGPT API. So this is an OpenAI API for which we have subscription. And then, the API would then process the prompts and either give us intents, which we then feed into our MCP server, and then be able to do things like, kick off naming transactions, kick off, batch transactions, etc. Or even call the ENS MCP server that I mentioned earlier with, fetching or performing those queries. The API, if it doesn't have, enough context to, figure out what the final intent is, it will ask follow-up questions, which will then, be forwarded to the user, and then the user will, type in these additional parameters. So the MCP server is basically, it's just a middle layer between the user and the API. And then, it obviously talks to the blockchain for performing these transactions. So this is, the architecture of our AI agent. yeah, let's go ahead. So this was, the Ask AI experimental agent that we have built. API docs. So what we have done is we've added a Docusaurus plugin to render these docs. We obviously didn't want to have boring looking documentation for the API, which would just tell you, okay, this is the endpoint, this is the request, this is the response, that's it. But what our intention was to make it very interactive, so that users who want to refer to our API docs can test them within the page itself. So this is how it looks like. We'll go to so on the docs section, we have this API menu item, and then on the left side in the sidebar, you have all the public endpoints we have at the moment. So for example, if you want to generate a random contract name, right? So in the UI field, you can enter the contract name either manually, meaning you have to think and then enter, or you can simply auto-generate it. So this is an endpoint that allows you to simply return an auto-generated name. And so you have examples in different languages. We also have a get score, ENS score endpoint, and I'll show you how this works. And what this endpoint basically does is, if you enter the chain ID and the contract, just a minute. Right, so we'll pull it from because I'm looking for okay, so let's see. Let's copy this and put it in the address field. So what we want is we want to get an ENS identity score for this particular contract deployed on Sepolia. So click on send API request and it returns 100. So an identity score basically tells you whether a contract has a primary name set, whether it only has a forward resolving name set, whether it has metadata set alongside primary name. So these are a couple of factors based on which an identity score is determined. So this is used to tell a user whether a contract has a good identity score, whether the contract has a primary name or not. And where you can see this is on the Block Scout contract details page. So we'll definitely take a look at it again in our next call. But yeah, for now, if you want to see what an identity score of a contract is, you can head over to Block Scout. Just go to any contract, and you should be able to see the identity score listed as a widget. So yeah, that's what we have built using the Docusaurus plugin. Let's go to
Yeah, Anil, if you have a question.
Yeah, that's a really cool feature. Just out of interest, just some of the other vectors that could be contribute to that identity score. So do you guys take into account things like, I guess, was a contract deployed recently? Have there been lots of transactions against that contract? I'm just trying to understand like what other things can constitute contributing to an identity score.
So right now, the only factors that contribute to an identity score is a couple of things. So for example, when the identity score is 0, what it means is there is no ENS record set, right? There's no primary name, there's no forward resolving name, If the score is, say, for example, 25, what it means is there are multiple forward resolving names. If the score is 50, then there's a single forward resolving name alongside metadata. If it is the score is 75, then it could either mean that there's either only primary name set, or there is a forward resolving name alongside some metadata. And finally, if the score is 100, so this is our Enscribe contract. What it means is it not only has a primary name set, but it also has metadata set. So so the score basically revolves around three things, which is names, forward resolving or primary, as well as metadata.
Got it. Thanks for clarifying.
Yeah. So yeah, for contract metadata, I would give the floor to Nishal, who will then explain what it is.
Yeah, thanks, Avi. Okay, let me just share my screen. Is this visible?
Yes, it is.
Okay, so contract metadata. So basically, Enscribe is behind, every contract should have a name and it should be visible on the wallet. And whenever you are checking through blockchain explorers or anywhere, you should understand, okay, what I am interacting with, even in your hardware wallet, instead of, verifying, okay, this is the address. Like it's really hard if you're using Trezor or any other wallet and you want to sign, okay, you need to check, okay, this is this right contract or not. And even in your wallet, like if you're using a normal hot wallet, so it's like really hard, and they're like address spoofing attacks and those stuff. So yeah, Inscribe is trying to solve this. Okay, just name your contract. At least it should have a forward dissolving name, because if let's suppose, take an example, if you have a org like uniswap.eth and it is linked to uniswap.org, right, or using DNS-sec. So you can basically say, okay, this uniswap.eth is actually owned by Uniswap organization, right? And if they set a forward resolving name to their maybe router contract, right, router.v2.uniswap.eth, then we can say, okay, I can trust this contract because it is under uniswap.eth, and uniswap.eth is a name owned by the Uniswap org. So basically, it's trying to creating a trust. But a trust can also be increased via metadata, like by setting a few metadata, or even it's like on-chain identity for contracts and even organizations. So let's say today the ENS is mostly used by profiles or wallets. Basically, the profile or wallets can have different kind of, let's see a name like maybe Vitalik.eth, right? Let's take this example. So if I go to this profile, okay, I can understand. So this is a site. Like mentioned, Vitalik. These are the official accounts which Vitalik own. And okay, this is the like website content hash. And I can basically get a identity of this wallet or profile, right? What this is. Now suppose I'm interacting with a contract, right? And I want to understand, okay, who created this contract, what are the documentation, um, what are the maybe the auditing stuff, like if this contract is audited. Because right now, if I want to find audit for a contract, I need to go through their GitHub, I need to go through their website, try to find, okay, is it audited, is it latest, is it audited the latest versions of the contract. So it's really hard. And even if you talk about versioning of contracts, it's really hard to understand the organization structure and even the structure of the contract and where it belongs, and how I can know if this like what's the identity of a contract. Similarly, what we've been trying to do is push the community towards a standard via contract metadata. So we recently created this NSIP draft NSIP for contract metadata, which is still experimental. And like later on, I will be talking with Lighthouse team to basically understand what they are working on. But just to give our perspective, what we have right now live in Enscribe website is contract metadata, as mentioned before in our draft NSIP. So I will just go through one of the app we have. So this is an Enscribe app. Let me just okay. So it's V2. It's a version 2 of our Enscribe smart contract, which you use to name the contracts, and let it load. Like so, if you see in here, right? Uh, this says a picture of how the on-chain identity for a contract can be can look like. So okay, so this contract belongs to Enscribe. They have these profiles like on if I want to check the GitHub repo, I can check from here. And then if I want to get their official Twitter link or Telegram link, I can check it. Okay, what is the official website, and what are the technical details, like what this belongs to, like security category, and what is the license. I can go to the docs directly from here. If I want to check maybe what's the contract or ABI and even source file, and if I want to basically check, okay, what this source look like, I can basically go, understand the yeah sources here. So this ABI and contract source file is behind the scenes Sourceify, or we are using Sourceify APIs. So once you verify your contract on maybe Sourceify or even Etherscan, then we can directly put it like the ABI and source files. And also, if you see the last, right, contract deployer. So who was the contract deployer, and who is the name manager, and who is the named parent. So basically, you can understand, okay, this contract has an identity, right? And I can basically trust via like, okay, what are the docs, what are the official sources. I can go through the GitHub and actually see that happening, right? And even if like I if I take another example of in Sepolia, just just a sample contract, like ideal contract, how it should look like. So we can also have the security audits right from here. So if this is a contract, and if it has the latest security audits, then they can rightly check from here. You don't need to manage in your maybe what you say um, through your GitHub profile or on your website or everywhere, and it's really hard for users to find your audit. It should be very simple. It should be on the ENS on chain, and like basically ENS can be used perfectly for this. And also, if you see, right, if I take this name, and if I check in uh, so it's deployed on Sepolia. So I will just check this name con1.cool.eth. So if you see, they're not if you see the records, like, okay, so for this I have set like many records, but yeah, even if suppose it doesn't have the description or maybe the URL, then and it is set on the upper level like cool.eth, then as a hierarchy, it should you know be able to uh, get all these properties from its parent. So what I'm trying to say is, suppose let's go to Inscribe again. And so since I'm on Sepolia, I will just go to Ethereum, and I will go to view metadata. So here, okay. So if you see, the record set directly under v2.app.inscribe.eth is just an address. But how are we getting other details? So if I go a level up, like app.inscribe.eth. Okay, so here we have set the GitHub, docs, license, and category, because these are the relevant text record which an app should have. Like, okay, where's the GitHub repo for this app? What are the docs? And if I want to, if I go a level up, like maybe on the inscribe.eth, then I can say, okay, here's the header, here's the organization, URL or Twitter or description. even Telegram, header and avatar, all this stuff. So basically, on each level, we have the relevant information, and once we go to the actual contract, which is okay, I can go from here. Uh, yeah, which is this. I can basically get all in a in a single page. So it's this is possible via the hierarchy system. And there's also a API which is like directly just go to contract metadata, the chain ID, and then the ENS name, and you can basically get all the set metadata according to contract, according to draft and SIP we have. But yeah, it's still experimental, and this is the API you can hit, and you can maybe the wallets and everyone can use this and basically show more data in their wallet. Okay, so moving forward, like we have today our guests from the Lighthouse team, and uh, yeah, let me just introduce Arnold and James. And yeah, welcome to the panel. If you can introduce yourself and what you're doing on the Lighthouse side.
Thanks, guys. I mean, James, do you want to do an introduction? And
Sure.
yeah, okay.
Yeah. So yeah, Arnold and I are from Lighthouse. We've been in the especially kind of DAO, on the chain governance space for quite a while, and recently have been getting quite involved in ENS. One, I guess, just to talk about more specifically our ENS related activities. We were sponsored by the MetaGov working group to work specifically on a metadata solution to allow people to put more detailed metadata on their ENS names. So very similar to what Enscribe has been doing with metadata specifically around contracts. But we really wanted to open that up to all sorts of metadata for all sorts of different purposes, because people use ENS names for all sorts of things, creating specific wallets, naming contracts, hosting or to act as delegates when voting on stuff and all of those kinds of things. So that's kind of what we've been working on. I can jump into showing kind of an overview of that system, Arnold, unless there's anything else we wanted to introduce first.
Yeah, for sure. I think like one of the things while you pull it up, one of the things that's really exciting about, I guess, how Enscribe is approaching this and how it overlaps with our work is that I think we both share goals and values that ENS can actually be the canonical root for a lot of this information, which means that I think even maybe in this demo, we actually didn't plan this, but this could actually be quite interesting. Like we could probably pull up the same records, Nishal, that you were just viewing, and we can see how that is going to be surfaced in our UI. And I think this really showcases and highlights the power of like why having a canonical root is important, because different subsystems, so like you're building a subsystem that's very specific for contracts, whereas ours is just more about like, okay, we want to try and visualize hierarchy. So what makes it really interesting is that that same information doesn't need to be repeated across multiple different providers, and we can actually rely on ENS as the canonical truth. A little bit small background, I guess, like we kind of came at this angle primarily from a sort of a governance data point of view, but over time we kind of have explored, generalized the system. And I think what's really cool is that like the fact that we have overlap between our system and how you guys have been designing it, and that means that we can have a sort of a unified front in terms of how a standard like this can proliferate across the ecosystem, which I think is much stronger, because what we don't want to be doing is creating competing standards where, oh, but the standard has a small deviation. Whereas I think what's interesting is, yeah, we've already got so much overlap. So I'm really excited to see how this can evolve together.
Yeah, like as you said, right? Instead of like having new NSIPs, like if we have a universal common which can solve different all the problems, like recently we are talking about NSIP 26, like the AI context, right? So instead of having fixed keys, right, for each use case, why can't we have a common solution which can solve different problems. I think that's what, when I was reading through the Enscribe, like it really struck me, okay, yeah, this is really a nice solution to this, the class and schema stuff. So yeah, like interesting, if you can explain more about that.
For sure, and I'll hand it over to James.
Yeah. So yeah, exactly. So yeah, the backwards compatibility and kind of solving the problem that people are already trying to tackle is kind of a big part of this. But just to kind of take one quick step back, as Nishal kind of alluded to during his presentation, ENS names are already hierarchical. So this right now, what I'm showing you is actually part of ENS's own ENS namespace. So they have wg.ens.eth, which is kind of a container where all of their working groups live. And they've actually created subnames for each of their working groups within ENS. And each of those subnames have their own subnames that kind of represent like wallets or other special functions within the working group. So you can already see that there is a natural kind of tree structure here that does show a hierarchy and organization. And our original idea with this project was, well, if a user were to be looking through this, they can see the tree, but they might not understand kind of the role of all of these different individual things within the hierarchy. So what if we could both label all of these nodes and let them declare for themselves what they are and what their purpose is, but also what if they could on the fly basically declare what additional context, like context specific metadata do they want to apply to themselves based on their role. So we've kind of, we're working on this ENS IP, which is in draft form, but has come along quite a ways. Just to kind of show like how powerful this could be in practice. So if we choose a node, we can actually attach a schema to it, which describes both the role within the hierarchy, as well as based on that role, what additional metadata you would expect to find on that node. So for example, if the working group department was kind of an organizational structure, we could label this as an organization, and then one of these subgroups could be a is a group, a working group, and then under here, the stream subname would be a wallet that belongs to that group. So by adding these, all of these labels can actually be stored on chain in the ENS text records, so that anybody who is loading up this data and viewing it can actually see in the hierarchy what roles these different nodes are expected to fulfill. Abjeet?
Yeah. So if you go back to the fields, right, the metadata fields, there were like versions mentioned in front of those fields. What are those versions? What do they represent?
So the so that kind of goes into the schema system, which we'll talk about next. So this was just kind of to show how labeling nodes to show their role is very powerful and helpful. But then within a role, you would have context. So contracts is a great example, because of all the things that Nishal shows off. So what the second half of kind of this standard is attaching schemas. So in addition to just declaring kind of what the label is, which we're calling a class, you can also populate a text record which declares a schema. And this is an actual JSON schema file which we have been uploading to IPFS, so it's immutable and always available. You put in the link to the IPFS schema, and then any consumer of that node, they can get that schema and parse it in a machine readable way to understand exactly what type of metadata is expected to be found for that node. And those schemas themselves are versioned so that if you are building, a consumer of this data, you could discover those schemas and decide, okay, we're going to support, version 2.0 of this schema that describes data for a specific contract or something like that. And then anybody who is using that schema, you'll know exactly what data to expect from their nodes and be able to digest it and use it. And then if somebody wants to, if the schema evolves, it'll have different versions, so you can kind of keep track of what is in each one.
James, I just linked to the schema for the contract, and maybe I think it would be interesting is like just to show the sort of evolution of how this kind of works. So maybe we could also like load up. Nishal, do you have a mainnet ENS record that has some contract metadata that we could load up?
So
If you can just post that
let
into
me
the
just
chat, and then we can just try and load up something different. But James, also, if you could just pull up that. So yeah, if you just put in like enscribe.eth, that should work, I think. Yep. And then our Explorer interface will just load up all the subdomains that are associated with that, and you can see how that's kind of just like surfaced already. So in this instance, V2 is technically a contract. So if you're using our standard, you would say, hey, I'm going to apply the contract standard to it. And that schema determines, hey, these are all the different fields that could be associated with it. So James, if we just pull up that node and just show like, add those optional fields.
Yeah.
Yeah.
So you can add in. So this is right now, since we've declared the schema, from that schema, it is pulling in all of these options. And down here at the bottom, we have the context-specific ones. So these are coming from the Enscribe, the stuff that you guys are currently using, actually.
Yeah.
And so you could specify, a specific value for each of these, and people would be able to ingest them. I guess these are not currently set on this contract. Is that correct?
Yeah. Well, it's probably our interface is not doing it properly because we haven't mapped it for that. But
maybe we didn't map it to the current.
If you also pull up the thing that I put in the chat, so people can just have a quick look at the actual raw schema. So it's important.
I'm trying to find the chat in our call, and now that I'm screen sharing, I don't see.
Okay, I'll paste
Does the button disappear? I don't know.
I'll paste you the thing in our Slack.
Yeah, if you could just send it to me.
Yeah, but I think like what's really powerful, and I think it's just speaking to that like the versioned aspect of it. So like right now, this is like an early version of what we believe the contract nodes should have. But I think as we find consensus within the community saying, oh, we probably need this to be in this format, blah, 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 we can actually declare this quite cleanly. And this is also like attached to the node itself. So as schemas evolve, we know what should be represented based on that point in time, if that makes sense.
Yeah. Yeah, so this is an example of what a schema would look like that would be published on IPFS. So this is our schema for contracts specifically, and it will list all of the different context-based metadata that we're expected to find. So coming from Enscribe, we've got compiled metadata, audits, where you can list the audits that you've received.
It's pretty loose at the moment, but I think, I think our next port of call will just be getting all the things that you guys actually use and just codifying it into like, version 1.2, and that would be it. Nishal.
Yeah, so one more question, like suppose we have these schema, right, alias or avatar, and if we don't set it, then it's treated as a null, right? Like the key and the value is just like null. And
Exactly. So
and
so right now, go ahead.
yeah, so no, just like I want to understand, like suppose someone wants to have a combination of some schemas, like maybe I want this contract is even another node, right? So it's like, okay, this is a wallet or a contract, and it also act as a maybe like a delegate or something else, like profile. So is this also possible, like if some schema from here and the schema from there, and then some null, or like I'm just trying to understand, like is it like only one node can have only one class and one schema?
Yeah,
So
that's actually correct. Yeah.
yeah,
Sorry.
and see, so the wonderful thing about schemas is that anyone can make any schema they want, and it is, as long as it is a valid JSON schema file and is machine readable, then anybody else can ingest that data. Of course, if you are building like an interface, you're only going to be able to design the interface around data that you are expecting. So somebody could, for example, start with this schema, and then they can make a copy of this and add in more attributes that are relevant to some other purpose, and kind of merge them together, right? And they could use that on their own ENS name, so that anybody who ingests that would get all of that data. Of course, if you are building an interface trying to use unified data, you might not understand that they're going to be mixing all this stuff together, and you might not design your interface around it. So we are, at least for our project, we're starting with creating this list of, I guess what we're calling like community, schemas that can fulfill these different roles that we have listed here, specifically for contracts, AI agents, wallets, organizations, humans, treasuries, all that kind of stuff. And we're hoping that those will become widely used. And then if you're building an interface, if you support all of those, then you'll know that anybody who's using one of those schemas, you can cleanly import their data. We're just designing them so that, one subname node has basically one of these purposes. And we want to encourage people to kind of separate their subnames based on those roles. As you can see here, hierarchically, if one node is labeled as a wallet, we would expect people to use that subname exclusively for wallet purposes. And that just keeps it very clean and easy to understand. And we think that's the best practices. Of course, we can't force everybody to do that. But by letting people build their own schemas, then it can kind of support anything. And
Yeah.
one of the questions that you guys brought up at the very beginning is kind of what I would say as backwards compatibility. So you currently are already naming contracts by putting up text records that describe all of the metadata. In order to make those supported by this system, all you would need to do is add a schema that already declares those exact same key names. And then anybody who has a system designed to read the schema will be able to pick up those key names in an automated fashion. So it'll be very easy for you to go back and add a schema to existing contracts. And all of the existing key names will just be picked up, and you won't have to redo any of that.
Yeah, I think
Yeah.
one more question, like, regarding this backward compatibility, like we have these profile and SIP 18, right? And there's some more profiles, like we have basically, fixed keys. So like, how do you see like the adoption? Like if people, just start attaching schema, I think that's the easiest like way to adopt, right? Like how do you see like the
Yes.
adoption for this?
So we've also in our draft ENSIP, we do kind of address that other ENSIPs already declare what are called global key names, which are the high level, fixed ones like avatar, description, things like that. So we acknowledge that those exist, and for your, if you are designing an application, and I guess we would also expect people who are building applications to design their own like standardized schemas that they want all of their users to use for their application. You are allowed to redeclare one of those global records in your schema. You just have to make sure that its use case doesn't differ a lot from how it's defined in its original ENS IP. So we have added in here all of the fields that have come from other ENS IPs. So we have avatar, email, keywords. These are all ENS IP5 entries. And so since these are all identified just by the key name, avatar, for example, this is established in ENS IP5, I think, to start, and then they expanded it in ENS IP12. But it means, this is a URI that points to an image, right? And so in your schema, if you want your application to make use of specifically avatar in a special way, you can add avatar as an entry to your schema. And in the schema, you can actually define the nuance of how that's used in your application. So you can add the description. It still has to be a URI pointing to an image, but in your description field in the schema, you can explain exactly how it's used, right? So for Enscribe, you could, define avatar as like an image that represents the owner of the contract or whatever use case you want.
Token symbol, for example.
Yeah, exactly. So yes, exactly. So that basically means that if you are building an interface to consume this data, by default, you should understand all of the fixed global key names that are declared by ENS IPs. But of course, you're not forced to support all of those if you don't want to. And then if somebody provides a schema, it might redeclare or call out those specific global names that they expect to use for their specific use case. And then you'll get that through the schema and know that it should be expected.
Yeah, makes sense. Yeah. And just a last question, right? Like, have you thought of any cons related to this approach?
We've definitely discussed it.
Like, a lot of different schemas, like people start creating their own schemas, then it's like hard for standardizing anything.
Yeah. Maybe
Go ahead, Arnaud.
Yeah. So I think one thing that is really interesting with this, and like you're right, there's going to be like a lot of potential diversification with schemas, which is why that the class attribute is actually like really important. And I think maybe James, if you can maybe just go to the root of the interface. So the cool thing about having the class attribute is that like basically anyone who's adopting this as a standard, we will be able to automatically sort of understand from an ecosystem perspective who's using what under what classifier. Now, within this, for example, like we know that over here right now, there have been 3 delegates that have been registered using the class delegate. However, underneath that, those 3 delegate schemas could materially be different, but it doesn't matter because we've defined a standard for how it could be consumed. So I think this is where the power comes in. And we think, we assume that people will anchor around like a few canonical class names. Like, I don't think anyone's going to be calling delegate something else. Like, it's very well known. Maybe there's going to be some sort of like fluidity around wallet, account, maybe smart account. But again, it doesn't matter. We think over time it will converge, and we wanted to allow that sort of like natural flexibility to be an emergent property rather than something that we prescribe. So, and I think this is even true with some of this ENS AI stuff, right? Like, we don't know necessarily what the specific domain names will be and what will emerge, but our standard allows for convergence over time.
Yeah, the class designator really helps with discoverability. So if you, for example, disagreed with the label of delegate and you wanted to like declare yourself as a voter or something, if you use the delegate name, that makes it discoverable by other software. So as I was like showing on my, my personal one, I labeled one of my subnames as a delegate, which means now dashboards or, automated software can search through the whole ENS space and find all of the nodes that declare themselves as delegate. And it can know that all of those are probably intended to be people that are voting and have voting power delegated to them. And like Arnold said, they might all be using different schemas, but at least you can discover them by their delegate tag, and then one by one, look at what schemas they're using and ingest all of their information. And if they have added information that you are expecting and know how to consume, then your application can pull that out and display it. So I think it's one thing we've really been thinking a lot about really is, how do people make use of this data? And, if you think about the internet in general, we have, like the HTTP communication standard, but once you've connected to a web server, and they're sending you HTML, like you have no idea what content they're going to give you. It could be anything. And if you've built a program that is calling web addresses and downloading stuff, maybe some content it'll understand how to use and other content it won't. And that's exactly the same here. We can't force people to put records in a certain way. All we can say is we've created a standard. The people who are publishing the data, if they do the work to match the standard, then other people will be able to consume their data as intended, and that's the benefit. So that's really the that's how we motivate people to rally around these standards. Is if you want to be discovered and want other people to see your data the way it's meant to be, then you have to follow the standard. Otherwise, you'll kind of get lost in the fringes of the blockchain, and nobody will be able to understand what you're publishing.
Yep. Yeah. I mean, rightly said. This could be the very powerful, thing which can be used, by orgs. And I think even this can be, this can really make the ENS as the single source of on-chain truth, which everyone can, look into. Yep. Definitely. And thank you, Arnold and James, for joining the call and explaining all the stuff related to this. And let's collaborate and get this stuff out. Yep. And yeah, all the best for you guys. Yeah.
Yeah.
No, and also just a note, thank you for also taking the time to read through and understand the standard. It's a lot of work, and also being forward-looking enough to also collaborate and develop the things. So yeah, I think next steps for us, just refine and understand what you guys have done and worked out with the contract naming stuff, and then see how we can fold it into this, and then make it better for everyone.
Yeah, definitely.
Marcus, do you have something to say?
No, I just wanted to come and listen to the call because you guys are doing great work. So just coming in, learning through osmosis and such.
Nice.
Peace, man.
Okay,
All right,
so
guys.
I'll just move forward with our last few slides. Okay, so some updates regarding the contract naming season. So we recently distributed the first phase of ENS token. We distributed around 5,100 plus tokens, and to 30 plus teams and wallets. And also there's still the contract naming season going on, 50 days left. And let's we encourage everyone, or the teams and organizations and projects, to start naming their contract, so it's easy for users to find and understand what they're interacting with. Okay, so what's next? So we are also working on a new Enscribe super app, which we are trying to get the alpha out by the end of this month. And we are also working on versioning registrar, which Abhi is working on. Basically, to give some context, what if there's a protocol and they have a contract, and they publish a new contract. So there can be a single registry where we can find the latest versions of all the contracts, and it's easy for the lookups and to get the latest versions of any contract. So yeah, Even the Nick from ENS is, we got some good feedback from him. So yeah, working on that. Apart from this, yeah, so Enscribe team will be at the ETHCC and we are presenting on 31st at 2:20 p.m. So if you're at ETHCC, do join us for the talk. And yeah, we will be, let's talking about this super app which we are building on. Yeah, I think that's all like from Enscribe team. Yeah, from this for this community call. Do you have any questions or anything? Yeah. Yeah, Marcus, please.
Hey, yeah, no, obviously, you guys are doing a great job, and I've been tracking everything that you guys have been doing, basically, attending calls and whatnot. I don't know if you like had seen like my messages in the group chat that we have together about like potentially like communicating to the recipients of the ENS rewards about how to participate in the delegate incentives program. Because I was a MetaGov steward in 2024, and one thing that we try to do is to distribute the ENS tokens to people who had participated in ETH Global, but like a lot of those tokens were like kind of like left idle, and either people didn't do anything with it or they just sold it. It'd be really great if the people who are being rewarded the ENS through this contract naming season initiative could be informed on how to participate in ENS governance, and also the potential like benefits that they'll get if they participate through the delegate incentive program, like just by delegating those ENS tokens to people who are like participating more actively than they are. So I don't know if you like had any thoughts on that, or like any strategy, or even if you've like spoken to like the Blockful team, because obviously like they're the ones like that put forth the proposal.
Yeah, rightly said, Marcus. Like I think we are communicating this to all the projects we worked with. But also, yeah, we'll be. I think we can talk it through the socials that if you have received some incentives via this contract naming season, then let's make this ENS DAO stronger by delegating your votes. Uh, and yeah, definitely. And the new proposal, right, from the Blockful team, I think we can include those in our next post and even blog posts, so people are aware of that and they can delegate their votes instead of keeping it idle. Yeah, thank you,
No, I think,
Marcus, for reminding that. Yep.
yeah, no, I think it's a great idea, and I'll probably raise the point like during the next MetaGov call, like if we have space, because obviously like people really focus on the SPP and retro, but like I think it's really important that we don't lose track or sight of like the importance of delegating, and also like the importance of like actually using our ENS tokens that we're receiving to like vote, or at least delegate to people who are voting. So I don't know if your team participates in the MetaGov calls. But like if your team and Blockwell's team are on the same call at the same time, that would be like the perfect time for me to raise a point and be like, hey, have you guys thought about collaborating together with your communications? And like, obviously like I'm like running the DAO social as well, so I can help on that front. But like just getting the word out, like, because one of the problems that we have, like, as a DAO in general, is like everything's like siloed out. And like I guess that's just like the nature of like working in a decentralized org. But just I feel like communication helps. So like just keep in mind, like, there's a MetaGov call, come through, I'll speak up, and then you guys can like figure out the rest, and I'm happy to help facilitate communications.
Yeah. I think we will be there we have it next week, right? So yeah, we'll be there, and let's coordinate here. Thank you, Marcus. Yeah, if we don't have any other question answers, maybe I can just stop sharing. Stop the recording. And thank you everyone for joining the community call. Yeah.
Thank you, guys. Thanks a lot.
Yeah, thanks for having us. Thanks for the good questions.
Okay, thanks, man. Great.
Bye.
Yeah.